In this lecture, we're going to talk about ways to measure how spread out data is. So if you think about a data set, you could have two different data sets that have the same mean. So for example, if you had the data points 9, 10, and 11, or the data points 0, 10, and 20. Okay? So this data set has mean, if you add the three values up, 19, 30 divided by 3. So the mean is 30 divided by 3 is 10. Here the mean is 0 plus 10 plus 20, also 30, also divided by 3, equals 10. So these two data sets both have the same mean of 10, but one is much more spread out than the other, right? This one is very close together. They're all right around 10. Here, they're much more spread out, okay? And so what we're going to do in this lecture is we're going to talk about the standard deviation. So the standard deviation is a measure of how spread out our data is. Okay? And so loosely speaking, you can think of it as kind of being the average distance that each value is from the mean. It's not quite it, but that's the idea, is you're thinking about how far values are away from the mean. Okay? So that's the idea of standard deviation. It can be a little tricky to calculate. Okay? So certainly if you have a calculator that can do it, you can do these calculations automatically. If you can find a calculator online that calculates it, you can use something like that. The most important thing to recognize is that there are actually two different standard deviations, and so your calculator probably has two different ways to calculate standard deviation. If you find something online, there'll be two different ways. Microsoft Excel has two different ways. Anything that we're looking for is going to be called the population standard deviation. Okay? Or it'll say standard deviation and have a P as opposed to an S, which is for sample. We're not going to go into the reasons why we use one versus the other. They're very close together. They give very similar values. I want to make sure you get the right one. So we'll always be using the population standard deviation. Okay? So let me explain how to calculate the population standard deviation. We'll calculate it for each of these two data sets. So what you're going to do is in each example first, so there are steps to this, right? So if you do it with your calculator, you can just plug it right in and take it. But if you want to do it by hand, it's a little bit more complicated. So first, take the mean. Then we're going to do each data value minus the mean, right? Subtract the mean from each data value. We're going to square those, add them up, and then divide by the number of data values. Okay? So 5 steps. It is a kind of a complicated process. And then actually 6 steps, I'm sorry. There's one more. And then we take the square root. Sorry, I forgot the last one. So 6 steps. A lot to this, more complicated than taking the mean. Like I said, if you've got a calculator that can do it, you certainly can use that. Okay? So let's do this for this first set, 9, 10, 11. Okay? So for this one. So we take the mean. The mean is equal to 10. Okay? So that's our mean value here. We found that already. If we take each data value minus the mean, 9 minus 10 gives us negative 1. 10 minus 10 gives us 0. 11 minus 10 gives us 1. So negative 1, 0, 1. Okay? We square them. And the reason we square them is because right now, if you just added these up, they would all cancel out and give you 0. Okay? Because some of them are negative and some of them are positive. And so squaring them is a way to avoid that. And we do this a lot in mathematics. So we square all three values. Negative 1 squared is 1. 0 squared is 1. 0 squared is 0. 1 squared is 1. Add them all up. We get 2. We divide by the number of values. So there's 3 different values, so we get 2/3. And then we take the square root of that. So the square root of 2/3. Of course, we'll want a calculator to do this. And we get 0.816. Okay? So remember I said here that this one was more spread out. What we're going to see is that if we do the same thing with this data set, and do it over here, we're going to get a larger standard deviation because the values are more spread out. So here the mean is still 10. When we subtract, though, each data value minus the mean, we get negative 10, 0, 10. 0 minus 10, 10 minus 10, 20 minus 10. Okay? Square those, you get 100, 0, 100. Add them up, you get 200. Divide by the number of values, so there are 3 values still. 200 divided by 3. And then we take the square root. And so the square root of 200 divided by 3, quite a bit larger, 8.16. Okay? So you can see this is a factor of 10 larger. Okay? And so remember what I said about this kind of being the average distance that they're spread out. It's actually kind of the square root of the average distance that they're spread out, but it's 0.816. These values are spread out about that much. 8.16, that's more how these are spread out. Okay? So that's computing the standard deviation. Let me talk a little bit about how it's used in theory. Okay? And we'll talk more about this when we talk about normal distributions. But the way that we think about standard deviation is if we have, for a large data set, which is, and I'm going to say, the actual thing that I want to say is that it's normally distributed, but I'm going to say that it's just kind of distributed in kind of a normal way, and we'll explain what that means in a few lectures. So basically what this means, distributed normally, means that most of the data is clustered around the center, around the mean, which is what we expect in most cases. Okay? So for a large data set which is distributed normally, 95% of values will be between the mean minus 2 times the standard deviation and the mean plus 2 times the standard deviation. Okay? And so we use standard deviation to kind of talk about how far from the center things are. Okay? So the reason we do that is because 95% of the values are going to be between 2 standard deviations less and 2 standard deviations more. Okay? And so if you've got a data set where you know the mean and the standard deviation, so say for example, you know adult gorillas have weights with mean 600 kilograms and standard deviation 50 kilograms. Okay? So say you're told something like this, what you know is that 95% of gorillas weigh between 600 minus 2 times 50 and 600 plus 2 times 50. So between 500 and 700. Okay? So that's kind of what standard deviation tells you. And so we use terminology when we talk about how kind of where individual data values are. We'll often say that it's so many standard deviations to the left or below the mean, or to the right or above the mean. Okay? So for example, we would say a gorilla with weight 750 kilograms is 3 standard deviations above or to the right of the mean. Okay? Because if you take that 750 kilograms, subtract off the mean of 600, you get 150. Divide that by the standard deviation, 150 divided by 3. So 750 minus 600 divided by 50 gives us 3 standard deviations to the right of the mean, above the mean. The book uses to the right of. I think above and below makes more sense. You can use either. You can say that it's above or to the right of the mean. People use both. Okay? Whereas if you had a gorilla that weighs 525 kilograms, right? 525 kilograms is less if you took 525 minus the mean divided by the standard deviation. So 525 minus 600 divided by 50, you're going to get negative 1.5. Okay? And so that is a gorilla that weighs 525 kilograms is 1.5 standard deviations. I'm just going to abbreviate that, below or to the left of the mean. Okay? And so we use this to talk about how far out things are from the center. Okay? Last lecture, we're going to talk about how to get mean and standard deviation from frequency tables.